All right. Well, good morning, good afternoon, good evening, everybody, wherever in the world you're located. And thank you for taking some time out of your day to join this really interesting and exciting webinar on edge computing and video delivery. This is brought to you by the Streaming Video Alliance, which you can visit at streamingvideoalliance.org to find all about our organization and what we're trying to do for the streaming video industry. So today we've got a really great panel of some super experienced and smart guys about edge computing. Now, obviously, edge computing is, not new, but it's really come into the forefront lately about, how its impact will be on video streaming and other use cases, obviously, like IoT and things like that. We'll be focusing mostly on video delivery here, but again, really great panel, kind of spreading, amongst service providers and technology providers. So guys who are, in the trenches trying to figure out how to make edge computing more ubiquitous and important in the way that we deliver video and the kind of video experiences we want to provide. All right, so just a little housekeeping. We will be recording this. We'll get this up onto the Streaming Video Alliance website as soon as we can, probably later this afternoon. You'll also receive an email when that's been recorded so that you can pass it around to colleagues and other folks who may not have had an opportunity to get this worked into their schedule. All right, so to start off today, what we're going to do is we're going to do brief introductions. So as you can see by the slide, we'll start out from the left and move to the right. And when we're all finished with our introductions, we'll jump into the questions we've got for today's webinar. All right, so let's start off with Brian Stevenson from Edge Gravity.
Thank you, Jason. So my name is Brian Stevenson. I'm with Edge Gravity by Ericsson, and I run ecosystem strategy and partnerships. I've been involved with the SVA for a number of years as a board member with Ericsson, and I'm part of that with Nokia. So hopefully I'll be able to actually provide some background in terms of what Edge Gravity is actually doing in the edge space, and how we're actually enabling video or new video workflows and workloads as part of that edge case.
Fantastic. All right, Brent from Hellastorm.
Thanks, Jason. This is Brent Yates. I'm the CTO of Hellastorm, and Hellastorm is a startup company out of Atlanta, Georgia that makes specialized hardware to accelerate video streaming and edge computing. We believe that some of the things that you're trying to do at the edge will be better suited, be more efficient, have more capability if you use hardware acceleration to do that. And that's one of the things I'm interested about in talking about today. So thank you very much for having me on the panel, Jason.
Fantastic. Steve Miller-Jones from Limelight Networks.
Thanks, Jason. Hi, everybody. I'm Steve Miller-Jones. I'm the VP of Product Strategy at Limelight Networks. Personally, I've been involved in the video space, online OTT video delivery for a little over 10 years now. As a encoding engineer, NOC, operations engineer, and then moving up through solutions and into product management and product strategy. At Limelight, our aim is to help our customers securely manage and globally distribute their digital content, and to really delight their audiences with the high quality of experience that we all come to expect of online video today. From an edge computing perspective, we're also, and I am involved in programs internally to build new services around serverless compute, functions as a service, and those types of services within the CDN as adjacent and supporting services for our CDN. So excited to be on the panel today.
Excellent. And last but definitely not least, we've got Mark Fisher from Quilt.
Hi, thanks, JT. Hi, everyone. I'm Mark Fisher. I'm head of marketing and business development at Quilt. Quilt is a software and cloud services company. We sell to service providers like Verizon, Telecom Italia, Korea Telecom, and our goal is to enable an edge cloud within those ISP networks to optimize media delivery, content delivery, especially video streaming within those networks. We've been doing this for quite a number of years now. 4 years ago, we were one of the founding members, and today are still a board member of the Streaming Video Alliance. And we've been chairing for some time now the Open Caching Working Group, where we've specified the way in which open caching operates within service provider networks. So it's great to join you today.
Awesome. All right. So I think the first place we need to start out in having a discussion about, really edge computing, the edge, video delivery, all that is basically answering the question, what is the edge? Is it a special set of software or servers? How does it differ from traditional cloud services like the CDNs that, really have had a sort of edge of the network for a very long time? So, maybe I'll just kind of open this up. We'll start out with Brian, and then, all of you guys can kind of jump on. But if we can get sort of some definition of the edge, that would be great.
So I think from my perspective, the edge is really a place. It's effectively where users actually terminate and where services are actually rendered and supplied to those users. And, I think from my perspective, I fundamentally believe that the next wave of internet will not scale without the active participation of the service providers. And so I think in partnership, what we're seeing is that those service providers are actually building a brand new business and market vertical that they call Edge Cloud. And I think, as you said before, there are a number of different applications running as part of that Edge Cloud. It could be video, it could be IoT, it can be autonomous vehicle control, those kinds of things. But I think the key piece that the edge brings is it really now begins to deliver sort of infinite network capacity. So, particularly with the rollout of 5G, we're seeing sort of massive scale access with the creation of these ultra small and ultra close access nodes. We're really beginning to see, and again, particularly around 5G, imperceptible latencies. So, you're seeing latencies down as low as 4 milliseconds. So for particularly around video applications like VR, like 360 video, and things that are actually involved in telecontrols, so VR with haptics and that kind of stuff, those imperceptible latencies become very, very important. And then I think the third piece is really this terascale device support. And clearly, as we move forward, and as we deploy more and more of these ultra small, ultra close access nodes, basically being able to support the 1.2 or sorry, the 125 million devices that are actually anticipated to access the network over the next 10 years. I think having an edge presence to do that becomes critical. So really, I think for us, and certainly from my perspective, the edge is really that one hop away from these devices.
Hey, Jason, if you don't mind, this is Brent Yates of Hellastorm. As a hardware manufacturer and we're putting servers in, we've talked to a lot of customers over the last couple of years, or potential customers for us, and we get a different answer for what the edge is from every single one of them. But the commonality is the edge is where they want to deploy in a non-centralized location that, just like Brian says, puts you close to wherever the end use case is. Even if it's one hop away or 2 hops away, it's closer than a centralized location. So I think the definition really varies from market to market on what we're seeing, but all of them are pushing compute resources from a centralized location out to some distributed deployment type of application.
This is Steve. I'd agree with that. I think there's also, if you look at the original definitions of edge, I think there's originally a concept that the edge was really the compute resources available in the device itself that would then generate some data out of usage and then send that forward. I think what we're seeing, and I think to support what the others have said, the edge cloud, as we talk about it, is the interconnection point for the end user's connection, 1 or 2 hops away at most. And I think if we think functionally about what it's doing, is it's performing and providing a layer of computational ability that can take the data that's been created by a device or an end user, or maybe in the case of video, some beaconing data or some information about what the user's preferences or some interaction they've had, and process that quickly, discarding perhaps the raw data, but making a decision with that in order to determine what to do next, and putting that decisioning close to the end user so you get those immediacy effects in your applications, in addition to being able to think about how you distribute the video more effectively for quality. That the edge is about enabling those rich data-driven experiences and dealing with vast amounts of data being created by the growing and increasing number of devices we have. So I think, the edge is in the edge of the network, as it were, And I think, you might think of it in sort of terms of it being a fog layer, but it is certainly closer to the user, so there's some immediacy in how the data is used and consumed.
Yeah, let me add to this. It's Mark from Quilt. And I think maybe just this needs to be said to be existential for a minute. The edge is first and foremost a state of mind. And I'm sure the panelists all agree with that one. I'm having some fun here, but in a more serious way, I agree with the panelists, all of them. We're thinking about the edge is a reason to move compute from central cloud functions closer to users because it's the right thing to do architecturally, economically, and operationally. We take a view of this through the lens of a service provider. So in our view, the edge is several things potentially. It's compute sitting in perhaps a central office, perhaps in the base of a tower for a mobile provider, or within the RAN anyways, in the 5G instance, which is what Brian mentioned earlier. The edge could be a set-top box or even a wireless gateway in the home. But in every case, it has a purpose, and it again, from a service provider perspective, that could be twofold. It could be to take on workloads that are a part of the service provider function. So that could be, supporting network functionality at the edge using compute instead of, purpose-built devices. But in our view, it's also for consumer-related use cases. In this case, video delivery, video streaming, content delivery, media delivery. And the edge is nice because it distributes the function, thereby increasing capacity, the flexibility of the infrastructure to respond to peak events. And it also, we believe strongly, enables new use cases that today just really aren't possible. And, a couple were mentioned before. We think of VR, we think of 360-degree, 8K streaming video, for example, self-driving cars. Those apps that really require this kind of ultra low latency performance in order to operate properly. So, again, our view of the edge is really seen through the eyes of the service provider.
Oh, that's very interesting, and that kind of leads actually into the second question for you guys. And I'm gonna target Steve on this a little bit, only because he's got a very strong background in in streaming video, and he's working for obviously a CDN that's a very big use case for them. But obviously putting content like video content closer to the end user can lead to a better video experience, right? By cutting down on the round trip time from request to fetching content and then delivering that content back out of cache if it's available. But and Steve, again, let's start with you first. What are some of the other ways that the edge can potentially improve the video experience?
Sure. I mean, I think from a perspective of a CDN, the edge of our network has always been a scalable compute resource available for us and our customers to use to distribute video at scale. We do a lot of things to manage that distribution. For a large live event, for example, how do we ensure everyone gets the content without overwhelming the networks? For popular content, how do we position it in the right place and provide that high quality, right? People are expecting OTT video just to work today, maybe versus a few years ago when it was a nice to have. It is firmly established, certainly for long tail content libraries and increasingly for live events as a first-class citizen in delivering content. So I think the edge is important. If we think about where the investments in the networks are, if we look at sort of trends by people like Cisco, for example, they point firmly to the more significant investments being made in the sort of metro and last mile networks for capacity, which give us the sort of guiding signal that that's where there will be availability of locations for us to put caches or more devices that we can use the computing resources of. So I think it's clear that we'll get into a position that there is more edge available further towards the user. So yes, getting closer helps deliver a high quality video experience in theory. I think where it also goes, if we think about the edge as a data processing service, a service layer for processing request information, and we think about what's happening in standards like ATSC3, for example, which in its application layer talks a lot about personalization of advertising, for example, or DRM keys, or we think about how we find content, right? The data services that go along with the video. I think the edge gives the opportunity to do a lot of processing about a user's preferences, what a user is looking for, and how they want to interact with the content. So I think what you get is not just the ability to distribute the content further and reduce latency and increase quality potentially by distributing the high quality objects further out, but you gain access to low latency compute functions that can help with content discovery, which we know from some of the big content libraries is a key differentiator for them. They have so much content, the key differentiator is how can I find what I want to watch quickly? And so I think the way in which the edge will additionally help video consumption and the end user is by providing the ability for these rich application environments to really have the high degree of immediacy we're looking for, and that gives us personalization, interactivity, and potentially more revenue opportunities for the content owner through how advertising and other data streams can then be integrated with the video. So I think the compute part and the data part of the edge is as interesting as the edge's potential for distributing the actual video content.
And I think Steve actually makes a very good point here. When you think about video, the obvious use cases for the service provider are entertainment, VR, 360 video, that kind of stuff. But I think as you look at video, and video is really now becoming more of a tool, it's becoming more and more interactive. So when you begin to add stuff like haptic control to video, when you begin to actually add the ability to provide teleoperations for a number of different use cases, I think having that low latency and really having that video service along with the compute located at the edge becomes really, really important.
Yeah, I agree. And to add to these points, I think, both Brian and Steve are perhaps pointing to these areas where edge compute is opening up the realm of new possibility for new apps, new experience, new capability, beyond just the, sort of expected benefit of low latency. I want to add to that too, in maybe a non-say technology way. One of the goals we have and see as a real opportunity is to bring the last mile service providers, the ISPs, into the ecosystem in a more, collaborative way, and encourage them for the right reasons to invest in this infrastructure. Because we're convinced that if that happens, if the big telcos, cable companies, mobile phone companies all see the reason to invest to enable these new use cases, but potentially for them new revenue, then we really change the entire value chain in a positive way for everyone, because the ISPs bring substantial resources. If they have the right reason to invest, they can create this edge compute capacity, phenomenally, distributed, massive edge compute capacity that's then there to serve these kinds of, use cases, but maybe more importantly, just to help the whole ecosystem scale. And maybe for a moment to put that in perspective, today in a mass live streaming event, it seems the records are in sort of the 10 million concurrent user range, where we know the Super Bowl is 100 million, the Olympics served 1 billion from a broadcast standpoint. So it's 2 orders of magnitude problem that we need to start to think about. If we're going to stream to all those users using IP instead of broadcast, then we need participants to invest who have the resources, both financial and operational resources, to really make this scale in a big way. So that's the other part I think that we see as real opportunity for the Edge Cloud.
Excellent. Well, so let's turn a little bit to the makeup of the edge. And this I'm gonna pick on Brent for this one, but obviously we've talked a lot about software virtualization, network function, functionality virtualization, lots of things about putting things on the edge in containers and using that to sort of spin more resources up as you need them. So obviously for elasticity and scalability, but obviously hardware does play a role in sort of the functionality that the edge is going to be able to provide. So I could, Brent, sort of you can start us off on this about answering the question of kind of what role will hardware play in the edge? Will they have increased GPUs? Will there be more powerful FPGAs? What hardware will be there, and how important will that hardware be in providing some of the services to video distribution?
Thank you, Jason. We're a big believer that hardware by itself can't solve the problem, just like software by itself can't solve the problem. And those two working together and using the right resource for the right job is how we optimize edge deployments and what the servers look like. We also believe that serverless compute is going to be the way it's going to be deployed at the edge. Those servers need to make it easy for the software developers to write applications, microservices, without having to know the details of what is available in the servers. We let an orchestration layer handle that. So will there be hardware? Yes. We believe that in order to make it more efficient, a lot of these edge deployments, you're going to have to make them more efficient because you have limited amount of resources in power and in rack space. And as hundreds of billions of devices come online, as we get this 2 orders of magnitude more increase in streaming requirements out there to support something like the Olympics, the number of servers is just going to explode. So making more efficient makes it more manageable. And hardware, specialized hardware acceleration, I think is going to be a big role in that. And that will certainly be GPUs to do AI type offloads. And we believe it'll be FPGAs to do other types of offloads. And with something like our solution, it allows your server resources that are running the software that we have, running in a serverless compute environment, running micro container type applications, to be multiple times more efficient at what they're doing. Because a lot of these workloads have common functionalities. They're all doing network operations. They're all doing RESTful state AI. They're all doing some kind of local storage for content cache or something like that. So having a server that's designed specifically for those types of deployments is just a no-brainer. It's the way you should do it to get that efficiency. So from our standpoint, there's going to be a lot of compute. There's going to be a lot of storage. There's going to be a lot of specialized hardware to do these individual functions to make all of these future applications work at the edge.
Yeah, I'd agree with that. This is Steve. I think what's really interesting to think about if you're doing, function as a service type serverless compute. So, you've got an orchestration layer that allows you to choose an amount of memory and then, run a function for a number of CPU cycles to produce or process some data. What's also becomes interesting then is the stack that's alongside it, right? So in addition to what the hardware offers you, an ability to scale those functions is, do you have a concept of local state or a local persistent state? So, if we think about how something like a function environment or a serverless compute environment adjacent to the CDN and our storage layers, what you get across the three of those things, I think is was being alluded to there, is the ability to persist state and reuse that again from a edge computing perspective, where you might think it's just ephemeral and you won't get any persistent state or ability to use that. So I think it's really interesting to see how service providers like Limelight will come along with not only services like we have today for CDNs, which offer a lot of logic, a lot of functional behavior that is customizable by configuration and that customers can influence, but also then bring their own code, their own functions to, and operate those adjacently and interact with the other service stacks we have. So I think the hardware is going to be really important, but I think the service stack that goes with it, as was mentioned there, hardware without software, you need the orchestration layers, you need the stack as well, but the hardware's got to get distributed.
Hey, Steve, this is Brent. A question on that. Do you think the orchestration layer needs local storage that's on a single server, or does it need to be distributed in a cluster across the services at the edge?
Yeah, I think you probably have a little of both, maybe. But in our view, you'd have a service, a storage service, which was adjacent to the compute layer. So you could keep something locally for some short period of time so it can be used again. Or you'd use, say, the caching functionality of a CDN adjacency to that, so you can create and forward some data, output, processed output from data you received. So I don't necessarily think it's all about just local storage to the function, but I think both a storage layer in the edge alongside the so-called serverless compute layer.
And have you thought about on the serverless compute making it multi-tenant, where different microservices that are completely third-party could run?
Yeah, that's what we're looking at. Part of our R&D effort as we go forward is looking at that right now.
Yeah, that's one of the things that we're looking at, as well as some of the 5G deployments, where you need to share that among multiple telcos. So there'll be one set of server resources at the edge, either in a container data center at the bottom of the base tower, an aggregation point, and then your servers are actually owned by one company, but software that's running on them is running from multiple different vendors.
Yeah, right. And then I guess the multi-tenancy challenge is then how do you know and how do you get the function, or let's call it a function for sake of argument, or your distributed container you want to run. How do you get that into place at the right time on request to provide the performance that the edge offers you? So there's some really interesting work to do to provide that orchestration layer further out from the cloud, where it traditionally has been held. So yeah,
and then you throw on the challenge of, let's say your hardware has specialized functions that need to be spun up in concert with certain applications managing that. So whether it's an AI application or an FPGA module that's processing, HTTP headers in order to filter them, something like that.
Right, it becomes an interesting challenge. Yeah.
So let's move on a little bit. That's a great discussion, and you guys kind of bring up a point, I think, that maybe is a little confusing to the industry. I know that there's a lot of questions about it, but let's and this is for Mark, because I know Quilt is doing a lot of work in really sort of exploring services and service at the edge, offering a service at the edge. And so the question I have is to Mark is kind of like, what will the edge have? What kind of resources will the edge have, right? Will it be a ton of compute, a ton of storage? Will there be something else? And then the sort of follow-on question is, how will content and owners and distributors really take advantage of those resources?
Yeah, it's a great question. So let me answer it in kind of two ways. First, in terms of the principal use cases we're seeing today, and again, through the lens of service providers, and then where this is headed. If you look at content delivery today, media delivery broadly, and the deployments we have, which many of them are in scale, customers like Verizon, where in the evening at peak, 20% plus of the downstream delivery is being handled by edge compute, which is, when you think about the scale of, say, a Verizon network, that's a pretty substantial number. The media delivery, video streaming task is got two parts, obviously. If it's VOD, that's a storage task generally, and the edge cloud's job is to really identify, store, and deliver the popular content, right? Not the long tail. So that's left to the upstream origin, perhaps, or a mid-tier cache. But then you have live streamings, and that's a compute function, not storage intensive. So both happen, depending on the night, depending on the programming, depending on what people are watching. That dictates the use of resources. And then the operator's investment in those resources is a function of how they expect to deliver streaming and content, and their knowledge and growing understanding of the mix of that. So that becomes fairly straightforward today. As time goes on, though, as I mentioned earlier, there's a range of functions, and we've been paying particular attention to Verizon and their 5G efforts and the use cases that they're thinking of. But there's a bunch of network functions, of course, that many of which can be very compute intensive and briefly lived, if you will, and therefore they need resources to be assigned. And then there's a range of other apps that their customers, they could be enterprise customers and vertically specialized, say in healthcare, manufacturing, or consumer apps like gaming, AI, self-driving cars, and so on, where they're a mix of both compute and store. And so the task of, as was already mentioned by the panelists, the task of virtualization, resource allocation, being able to understand what's happening when workloads are arriving and how to assign resource to them while maintaining service levels across the board to everything is really interesting. I think broadly, the last comment I'll make is, if you think about the transition or transformation inside service provider networks, they're really changing gears a bit from the standard view of build lots of network transport capacity to handle traffic flowing across their network and whatever it may be, to this mix of edge cloud, edge compute, and network transport, and balancing the two to optimize the way in which traffic is delivered across their network. And this is really, a fascinating transformation for them, and a fun dynamic within the industry to be part of.
Anybody else have some thoughts on that? Steve, Brent, Brian?
Yeah, I mean, if I think your question was about what's being deployed, but I think use cases are always interesting to turn to as well, to think about what in a video use case, right? We're talking about the availability of state, say for VOD, right? Some state and some compute for live, but then what do we also use the compute for during those processes? So you look at use cases like, say, digital watermarking, right, or forensic watermarking for video. You have to make some computational decisions about what to give the end user, and the edge becomes a very compelling place to do that for its availability and low latency. So then you think about any kind of manifest manipulation, you think about A/B testing, you think about how do you do really localized targeted server-side ad insertion, and suddenly the use cases, what you'd use this for, come to light, and you see how it fits alongside, say, the ability to get those video files, those chunks, further towards where the users are requesting them for their latency and for their quality. And for the scale as well, right? So to the point of audience size, you've got to build for peak, but you also got to build for the range of services that go with that. So if we have a peak event, but because of how the content needs to be protected, we have to do some computation every time for every request for the user, or calculate a different manifest, or check their advertising preferences during the ad break. Suddenly the compute at the edge is really, really important for that immediacy. So I think the use cases dictate where, not necessarily what hardware we have, but what the kind of service layers need to offer at the edge.
And what Brian is talking about is exactly the types of computate resources that we believe that having specialized hardware that is flexible can solve. Because while we don't know what all of those are right now, we all know they're coming. And being able to do those types of automatic, every single request processing, to do predictive analytics, to do AI, to do ad insertion, all requires you to look at every single request every time and make a decision. And you just can't, at the edge, you just can't keep throwing servers at the problem. You have to make them more efficient. So I think there's going to be a role for specialized hardware in those decision-making processes.
Well, and that leads us, to my next question, which is, as you guys are talking about sort of resources, both hardware, so physical resources, and software at the edge, that will, kind of come together to provide, call it a platform, for video distributors and content owners to do other things than just deliver video. What are some of those video processing activities? Is it DRM? Is it transcoding? What is going, do you think, is going to be moved from, from that sort of central processing location out to the edge to provide for, again, a better video experience? And maybe we can start off with Brian on that one.
Yeah, so definitely there's a lot of applications around core video that will actually probably end up in the edge. Things like conditional encoding, so effectively adapting that video to the device or to the network that it's being delivered over. But that will probably move to the edge. It'll probably be done more in real time than something actually sitting at the core. And again, going back to, I think it was Steve's point, being able to add additional layers of security onto that video through, personalized watermarking, through even personalized DRM, moving that functionality to the edge really does make a lot of sense. But we're also seeing a new set of applications coming along that's really driving the user experience, or really allowing the user to actually find, discover, and really select better content. And so if you look at a lot of the AI applications that are actually being deployed at the edge, these are applications that are actually tracking what you're doing. They're tracking your interests. They could even be integrated with your Twitter feed. So getting a lot of information coming from social media. And so these are really influencing how users are actually being directed to content, how they discover content, and really how they, how they begin to consume sort of next generation television services. And so again, for a lot of these AI type services, being that they're very personalized towards the user, the edge is really the best place to deploy those.
Yeah, I think those are some really good use cases right there. And if we then think about richness of content, I think we then also start to see other areas where doing that computation closer to the user is beneficial. So I'm looking at things like, you might call it augmented reality versus VR, but if you're going to interact with a video by choosing which subtitles you want to look at right now, or which stats do you want to overlay on top of the team game that you're looking at, or your piece of VOD content. Show me all the other programs this actress has been in, and you suddenly start to have a lot of capability of interaction with the user. You don't want to send all of those little pieces of data that I just created by interacting with my app back towards a cloud for some compute to happen there and come back out. You want to offload it quickly so your app can show you that you're working, right? While it goes and works out what to do, or it pulls a cache piece of data out, or it goes and accesses a data feed to give you, right? The immediacy that people are demanding in the devices is really driving the innovation around the content. AR for advertising, right? Localized advertising, to me, well, if it's true ultra local, then maybe the edge has the adverts for that local region anyway, right? And they get inserted with the local brand name for whatever sports drink it is that's being advertised with the football, right? So it's that kind of augmentation of the content where I think it needs a little bit of compute to happen quickly and often, based on our interactions, in addition to security, in addition to, perhaps, bitrate transitions, perhaps even, multiplexing for different containers and formats. Those are all interesting, but I think the content play and our interaction with that is also really going to drive the need to have compute close to where I am.
Yeah, agreed. And just as an example of this, we're working with a VR company whose focus is on VR experience and live events, where I can sit at home, watch the live event, in basically near real time, and have the ability to look around the field of play and so on, watch particular athletes and plays unfold. And there's obviously a signaling that happens as I'm wearing the headset, turn my head to watch a particular play or athlete. That's a signal to the network to send me that content. And of course, in this case, having that delivery, the signal processing and the delivery take place from the edge, a server literally down the street, so to speak, in your neighborhood, could be or will be a vastly superior experience, and enable these kinds of experiences on scale.
Right, or imagine you needed to do a quick time sync, right? And you need to quickly check with a distributed time feed, right? How far off live are we?
Exactly.
To synchronize that piece of VR. You just talked about where's the local, ultra local service you can hit that tells you whereabouts you are in the time frame, if it's not with the video, right? And there are some formats that make that difficult, and some frameworks that offer it up, but having that available is one of the things we're looking at and working on at the moment with some of our low latency streaming, is how do you provide the localized time data as well. So it's really interesting to create these rich experiences.
Yeah, agreed. And just to throw one more maybe unexpected one out, we've heard from a few service providers, is incredibly the upstream traffic. So, you know, all these homes and businesses who have maybe 24/7 security monitoring in effect, or whatever they may be sending upstream, but a tremendous amount of traffic from devices, smart devices, coming into the network. And often cases, because of the kind of asymmetrical nature of networks, the upstream path is not as high capacity as the downstream path. And so service providers are saying, hey, is there a different way to think about how I ingest this, you know, make sense of it, and then as needed, send it onto the cloud. So it's a whole nother set of use cases that, you know, maybe need some optimization.
Yeah, I'd agree with that. We look at some industrial video use cases. We are helping some companies do analysis of video from you know, industrial complexes to look for differences day to day in infrastructure, and they need to offload the pictures quickly so they can do the analysis quickly, and pushing it to the cloud whilst it works takes a long time, right? And as they prove out the technology is useful for being able to identify, you know, a small difference between images to identify something that needs some maintenance, they want to improve the time it takes to do that. And that's really where it comes into play.
That's right.
Fantastic. So, oh, sorry, go ahead.
No, that's right. I was just going to say, from our standpoint, from as a flexible, specialized hardware manufacturer, what I'm hearing on all of these, and the other panelists have a much better idea from a high level of what kind of services are going to be interesting. What I'm hearing are low-level features that are common across all these, like encoding, compression, you know, local storage, pattern matching on all the network traffic, and background transport, header manipulation, live sync with buffering. Those are all sort of common features. And if you're going to try to do all of these features at the edge where you have limited power and limited physical space, then I think those are the types of things that we would look at offloading dynamically into a specialized piece of hardware.
Yeah, and let's continue on sort of the specialized piece of hardware. You know, because you know, something that we've talked, you guys have talked a lot about is, you know, as we move services into the edge, you know, obviously having the resources available, you know, to tackle the intensity of that application, and maybe even pushing that off, you know, at some point to either a piece of hardware or something else. But, you know, some of the things that we've seen in the video space right now, like, you know, call them compute intensive activities, such as, you know, real-time analytics or automation or, you know, AI or machine learning. You know, they haven't historically been happening in real time, right? They're usually delayed because they're going back to that centralized cloud, and somebody's having to deal with it, and then it's, you know, being, you know, going back to the user. So, you know, will the edge, you know, and again, maybe using, you know, some specialized piece of hardware in addition to the software, will those technologies, you know, enable some of those functionalities to happen in, I guess, realer time? You know, and will it improve the sort of, you know, video experience, and maybe even promote more interactivity?
The challenge on that,
Brent,
from my standpoint, is whether there's enough processing capability to ever keep up with the flow. You're certainly not going to be able to do it centralized. The edge is probably the only place where you could do it if you could throw enough GPU resources, software like we have that integrates closely with the hardware. Right now, the challenge is just getting the efficiency up to make the edge work for the current set of workloads. I mean, streaming is going up at 35% annually. CPU power is only going up at about 3% annually. So those curves aren't going to cross. And the only way you're going to be able to keep up with the demand is to do something specialized. Now you're throwing on additional features for AI, real-time analytics, predictive marketing, where you're looking at those data flows and trying to do that real time. I think edge is the only place you're going to be able to do that, because you're spreading the load out.
Yeah, go ahead.
Sorry, I was going to say, I actually completely agree with that. I do, however, think the edge is actually really valuable in terms of real estate. So I don't think you're going to see all the applications really migrate from public cloud to the edge, but I think you're actually going to see those where it does make sense to give you that immediacy and really give you that real-time feedback being deployed at the edge. And I think to optimize that, you know, just touching on Brent's point, we're going to see a lot of specialized hardware deployed at the edge So we're definitely going to see GPUs, we're going to see FPGAs, stuff that can really optimize that edge compute and really drive throughput on it. And if you really look at sort of public clouds today, really the cost of compute have become sort of somewhat insignificant. So storage and bandwidth costs have plummeted. Really spinning up shared virtual compute costs today costs almost nothing. At the edge, though, the amount of real estate, the power, the cooling, everything that you have at these ultra close, ultra small cell sites is actually very valuable. And so I think the types of applications that you're going to see deployed there will be ones that really make sense and ones that can really benefit from those locations.
Yeah, I think that's going to be really interesting, because in the different layers of edge in the I think it's commonly called the fog, like in the sort of connected cities, you might have a local cache that's collecting data for forwarding as a larger blob or block of data that then is processed a little further up. And if we then think about video, from a CDN perspective, we've been pushing, a specific set of functionality further and further to the end user for a while. But as you get further out, if it's more expensive, you've got to work out quickly which of the operations you want to have take place that far out. So, can you pass your beacon data up? Is it okay to pass your beacon data up, a few more milliseconds to, the edge of a metro, where you can then do a little piece of aggregation and then make that available to a data service or a set of APIs for analysis, right? So I think you've got to pick very carefully which functions you're going to separate from your larger application or business workflow or media workflow that needs to scale horizontally quickly on demand and benefit from a serverless compute environment. And then you've got to choose from your cost perspective, which do I really need to do, to the point close to the cell, or which do I need to do in the metro, or which can I do just outside of the metro, and how do I choose and when do I get those resources allocated, right? Who is offering the service that you can hit and will resolve you to the right place to do that function at that time? So that's one of the things we're looking at, in combination with how we expand the CDN and where do the sort of media delivery nodes go, and that form of compute, how do we extend that with our partners? But also, how do we give someone who needs to offload some data for processing, how do we give them a resolution of a resource that's in an appropriate place? And that's quite a challenge.
I think Steve's point is excellent here, and I want to add to it because, there's maybe the balancing of a couple considerations that are key. So there's just this operational point, which is, thinking about it architecturally and operationally and say, where do I have the optimum solution? There's no point in assigning tasks out to the edge if they can be done just as well further upstream. The other point, though, is who's paying for this, and how does that resolve into a profitable business, let's say product line, service offering, and so on. And I think these two have to come together in an important way. It may not be that we, parse out specific compute tasks and say, hey, that's better at the edge, so let's do it there. Maybe as things move forward, there's comprehensive offerings. We've talked about a number of these already, and there's an industry who's willing to pay, an enterprise or maybe consumer through subscription and so on. And so because of that, there's a clear motivation to package that whole solution in such a way that performance is optimized at the edge. And I think this is one dimension that's still a work in progress. As we talk to service providers about 5G use cases, for example, the constant theme is, how do I monetize this in such a way that really, it makes sense of my 5G investment? And I think that's the other task that the industry has to take on.
All right. Okay, so we're just about out of time. We got about 8 minutes left, and one of the questions I really wanted to get to was about the future, right? So obviously Edge, it's kind of funny, right? Edge has been around for a long time, but Edge is now really new. I think it's because, the definition as you kind of described it, as you all described it at the beginning of this webinar, is changed. It's really expanded. I mean, I almost see the Edge as sort of a platform, upon which lots of different things can be done. And, video delivery, it has a great potential to help with the video experience. And help providers and distributors and content owners do more things with their content closer to the end user. But obviously, the edge is going to change, right? I mean, I think it's going to evolve. It's going to morph and, expand and grow. And what I'd like to do sort of, as we end out this webinar is to kind of get your all sense on, how that edge will evolve over the coming years. What kind of functionality, and this is totally pie in the sky, but what kind of functionality may be available, to video providers in the next, 2, 3, 5, 10 years. And what we'll do is we'll kind of start with Brian and we'll just go down the line and end with Mark. So Brian, what do you think is going to happen to the edge in the future?
So really, I think we're really only in the infancy of edge. I think it's actually going to continue to grow, and we're going to probably see a lot of changes over the next at least 5 to 10 years. One of the key things I think we're going to see, though, is this formation of global and local alliances. And so it's really, I think, as I mentioned before, we really don't see the next wave of internet scaling without the active participation of the service providers. And so if you look at really some of the stuff that we're doing with Edge Gravity, we have already built out this edge infrastructure, federated edge infrastructure with 100 plus global service providers. And so we're really seeing this formation of this global local alliance, and I think that's really going to continue. And so really, what do I mean by that? So clearly, these service providers have local presence. They're in a lot of different markets throughout the world, and we're actually seeing them now leverage that local presence to actually provide compute, to provide throughput, and to actually provide data acquisition and aggregation for a lot of global brands. And so whether these global brands are people like, the studios, the content owners, or even, people like, for example, IBM or large global enterprises, we're actually seeing that formation of global and local alliances actually happen today.
Fantastic. Brent.
Well, I'm not sure where the edge is going to end up being 5 years from now, but we have a vision for where we're trying to push it from talking to various customers over the last year. And that is going back to the conversation about a serverless compute environment. We believe that it's going to be that kind of deployment where rather than you just dropping a microservice onto Amazon's cloud, now you're dropping a microservice onto Limelight's network or Edge Gravity's or Quilt's, all of which have a function for cost based on how close you want to latency, how kind of server compute capacity you need, how close you need to be to the customer, and where it's actually run is dynamically allocated. And the same thing happens with the hardware that's available. So if you say I need to process, let's say 400,000 messages per second, and I need to do header manipulation, then that's a feature that Limelight has, and Limelight can price that out on the edge. And it's all managed and orchestrated in a serverless computing environment magically. Now, how we're going to get there, that's a long road, but I think that's where we're going to be pushing the edge to evolve from the people that we're talking to.
Great. Steve.
Yeah, I think Brent's comment, I think that's a really exciting view of it, because I think it is about the platform, platform as a service of serverless compute and edge computing. I mean, we're already as Limelight working with Edge Gravity on both extending our reach and where our CDN nodes are placed with them, which is really exciting, and it moves that functionality further out. I think if we look in our crystal balls, what's difficult to see is what the full consumer oriented applications are, but I think what is easier to see is perhaps that the platform, if I have an AI framework I want to use, can I deploy it on a platform as a service environment that helps me gain access to those compute resources when I need them without me having to worry about how to deploy them? And I think that's key. So, wrapping cloud API functions wrapping multi-CDN environments, looking at beacon and data services where you need to consume data quickly in order to understand what's happening. Those are all the obvious, sort of computational activities that we'll be doing. I think the platform play is critical, and the orchestration layer and the allocation of resources on demand, and that's what we're looking at. And I think that's really exciting. And I don't want to have to say to anyone, hey, I'm going to dictate how you write your workflow, right? So it's not necessarily SaaS. It's definitely a platform play.
And Mark.
Yeah, I want to echo this because I think this is the right vision that we've heard now from every one of the panelists. What does the future have in store? I see it as in the same way that anyone can go and order up compute from AWS in a very similar way. There'll be a marketplace, and honestly, we at Quilt see this as kind of a mapping nicely to the sharing model that's so popular today with Uber, Airbnb, and the rest, where we have an aggregated set of service provider networks, ISP networks, globally tied together with a smart mediation layer, a cloud control plane, if you will. I'm a developer somewhere. I know I need this kind of compute resource, this number of transactions, maybe in this particular country, region, market, and I'll go order it up. And there's a competitive market for this. So various people can bid on delivering this. And I order it, I receive it, and the delivery of that, all the infrastructure that we've been talking about through this entire call, it's left up to the ecosystem people like us to make sure it's there to do the job that's been paid for. I think that is the vision for the edge cloud, and I do think we're on our way towards it. So it's really good news for us.
I think it's one of the more exciting markets we could possibly be in.
You're here. Yeah,
I would definitely agree. Yes, absolutely. Indeed. All right, guys. Well, that's a wrap. We are at the end of our time. So I wanted to say thank you to our for listening into a really very interesting conversation about some of the aspects of the edge and how that'll apply to video and the video experience. So again, thank you very much to our panelists, Edge Gravity, Hellastorm, Limelight Networks, and Quilt. That was fantastic. We will get this published onto our YouTube channel and then onto our website as quickly as possible. So again, thanks everybody. Have a wonderful rest of your day and take care.
Thank you.
Thank you.
Thanks everybody.